welcome back. Today, we join a craftsman building a shelter from the ground up, relying on hand tools and the raw timber surrounding him. Splitting a base log with iron wedges requires reading the grain. A slight miscalculation in the strike sends the split spiraling off-center. The foundational sill dictates the alignment for every course above it. D. A curved gouge clears the excess material rapidly, forming the concave saddle. Tracing the lower log's exact profile ensures a weather-tight fit without the need for synthetic sealants. Striking the chisel with a wooden mallet prevents shattering the tool's handle over repetitive blows. Working off the ground on sawhorses spares the back during long hours of shaping. Hardwood pegs driven into pre-drilled holes act as structural dowels. Unlike iron nails, wooden pegs shrink and swell with the surrounding log, maintaining their grip as the seasons change. The friction locks the walls into a single rigid unit. Precision joinery begins with a scribe. By outlining the contour of the supporting log, the builder transfers the geometry upward. The deep V-notch removes the bulk of the waste wood quickly, allowing the heavy timber to settle firmly onto the corner joint. Every strike of the axe must be calculated. Removing too much wood weakens the corner, while taking too little leaves gaps for wind. Gravity alone holds these early courses together, converting the massive weight of the raw pine into structural stability. Spanning the foundation with heavy crossbeams creates the load-bearing grid for the floor. Metal joist hangers provide a modern reinforcement to the traditional log frame, locking the horizontal beams against shear forces. Checking the assembly with a spirit level prevents the structure from settling out of square. Carving connection points directly onto the joists ties the lower framing into a rigid base. The axe work here must be shallow and precise to maintain the beam's load capacity. Natural moss laid between the courses serves as a traditional, breathable gasket. It compresses under the weight of the upper logs, expanding to fill uneven gaps. The scribe tool marks a parallel line along the entire length, guiding the lateral groove that will cup the log below. The interlocking corners keep the building from spreading apart, while the grooved lengths stop the elements from pushing in. It is a slow rhythm of lifting, marking, dropping, and carving. A properly cut saddle notch cups the lower log tightly enough to shed rainwater, trimming slivers with a hatchet dials in the final tolerance. Lifting these pre-grooved timbers requires a careful balance of leverage and momentum. Once the log drops into its resting place, the joint is checked for flush contact. A well-fitted wall effectively seals itself. The adze hollows out the wide channels where an axe cannot easily reach. Its curved blade sweeps across the grain, scooping out long ribbons of pine. As the walls rise, the physical toll of hoisting timber grows steeper. Darkening clouds force a hurried pace, turning routine trimming into a race against the weather. Rain on freshly stripped logs creates a slick, dangerous working surface. A specialized double-level scribe tool keeps the complex corner geometry true, even as the builder works from precarious platforms. When the storm finally breaks, the tools are packed away to prevent rust, leaving the raw structure to weather its first rain. Moving heavy timber to the upper courses requires mechanical advantage. A simple wooden ramp and a rope act as a primitive inclined plane, halving the lifting effort. The friction of the bark against the ramp acts as a natural brake. Once hoisted, adjusting the log with a metal pry bar leverages hundreds of pounds into exact alignment, with only a fraction of the effort. As the afternoon shadows stretch, the work moves high onto the scaffolding. Carving at this height leaves little room for error, requiring a steady stance. By the next day, the interior space begins to define itself. Window openings break up the solid walls, framing the surrounding forest and allowing cross-ventilation. Working inside the rising structure shifts the acoustics, reflecting the sharp ring of the hatchet off the fresh wood. The final courses dictate the ceiling height and determine how effectively the eventual roof will shed snow. The uppermost logs are the heaviest and the hardest to maneuver. A long pole provides necessary leverage to pivot the timber into its notches. Working into the fading light, the builder relies on muscle memory as much as sight. The scribe marks the final connections against a vibrant sunset, signaling the end of the vertical wall assembly. Getting these top courses perfectly level is critical for the roof framing. A vertical support post introduces a new vector of stability, anchoring the horizontal expanse. Securing it with heavy hardware guarantees the roof load will transfer straight down to the foundation. Every notch and groove cut into these final logs must anticipate the downward pressure of the upcoming roof deck. The handsaw bites cleanly across the grain, severing the wood fibers for a crisp shoulder on the joint. The walls are now complete. A rusted iron spike, driven deep into the heartwood, pins a spirit level checks the plumb line, ensuring the roof's weight won't push the walls outward. Even a slight deviation here multiplies over the span of the rafters. The chisel clears a square housing for the roof beams. Clean right angles are essential to keep the horizontal rafters from rolling under heavy loads. The quiet hours under a full moon offer time for tool maintenance. A dull axe requires more force to chop, increasing the chance of a dangerous deflection. Keeping a keen edge on the high-carbon steel is as critical to the build as the timber itself. Morning mist dampens the wood, making it slightly more pliable under the axe. The day begins with preparing the heavy structural beams that will span the open cabin. Inside the shelter of the finished walls, the workbench provides a stable platform for precision cuts. A steel squares the roof joinery is marked at true 90-degree angles. Deep square knot sausats are chipped out to cradle the intersecting roof logs. This mechanical interlock resists the sheer forces of wind and gravity. To raise the heavy roof timbers alone, the builder rigs a rope and pulley system from the upper framing. Suspended in the dusk, the ridge beam hangs ready for final placement. Blue ratchet straps act as temporary bracing, clamping the rafters tight while the permanent joinery is measured. The metal scribing compasses trace the complex intersection of the round logs. This transfers the exact curvature of the rafter onto the ridge beam, guaranteeing maximum surface contact when the two logs merge. Carving deep into the timber high off the ground demands absolute control of the chisel. Each joint is test-fitted, adjusted, and refitted. The roof frame takes shape as a self-supporting triangle, inherently the strongest geometric structure for bearing downward pressure. When locked together, these logs will distribute the massive weight of winter snow down through the walls to the foundation. The distant roar of chainsaws interrupts the isolation. The surrounding forest is no longer the quiet refuge it once was. To save the work, every log is tagged and numbered. The structure must be dismantled. Prying apart joints meant to last. A lifetime is a grueling reversal of progress. Rain swells the wood fibers, making the tight corner notches stubbornly grip one another. Every heavy log wrestled down to the floor. Joists represents hours of lost labor. The weather adds weight and hazard to a process already fraught with frustration. By twilight, nothing remains but the concrete piers. The site is erased. A heavy trailer hauls the disassembled cabin deep into a new, remote stretch of timber. The first tagged log finds its familiar place on a fresh foundation. Because the complex joinery is already cut, reassembly is a matter of muscle rather than measuring. Natural sheep's wool replaces the original moss. Unrolling, the wool along the lateral grooves provides a superior, moisture-resistant thermal barrier against the harsh climate. Vertical posts are bolted securely into the reassembled walls, providing rigid support for the roof's peak. The numbering system proves its worth as the massive ridge beam is hoisted back into position. The complex rafter joints, carved weeks ago at the old site, slip seamlessly into place. The interlocking logs immediately re-establish the structure's rigidity. Working high on the rebuilt frame, the builder secures the final rafters. The transition is complete. The cabin stands tall again. Sunlight filters through the restored skeleton. The setback has been overcome. Screwing rigid wooden planks across the rafters creates the structural diaphragm of the roof. This solid decking prevents the rafters from shifting sideways under heavy wind loads. Securing the boards from the outside in closes the open canopy, dramatically shifting the lighting inside the cabin. Every plank fastened to the rafters adds enormous lateral strength to the entire building. The steep pitch is designed specifically to shed heavy rainfall and encourage snow to slide clear. Pulling materials through the canopy requires careful rigging. The pink utility rope acts as a reliable lifeline, hoisting the final heavy planks to the peak. Working near the ridge is treacherous, relying on the grip of boots on raw wood. A temporary tarp shields the fresh decking from moisture until the final metal roofing can be installed. In the fading light, the focus shifts to crafting the exterior details. A cardboard template ensures perfect uniformity across the decorative rafter tails. The handsaw navigates the tight curves, cutting away the harsh right angles to create a softer, traditional profile. While these curved fascia boards serve an aesthetic purpose, they also protect the vulnerable end grain of the structural roof beams from wind-driven rain. Sanding the freshly cut curves removes splinters and opens the wood pores. A smooth surface ensures the protective chemical treatments will absorb evenly across the entire board. A copper-based wood preservative saturates the pine, turning it a vibrant green. This chemical barrier prevents fungal rot and repels wood-boring insects, drastically extending the life of the exterior trim. A synthetic, vapor-permeable membrane is unrolled horizontally across the roof deck. This highly engineered fabric allows internal moisture to escape the cabin while completely blocking external rain and snow. Stapling it tight prevents wind from tearing the sheet before the battens are installed. Wooden battens are then secured over the membrane, creating a vital air gap. This ventilation space ensures any condensation that forms under the metal roof will dry out safely, preventing rot from attacking the wooden deck below. double the protection, heavy black roofing felt is layered over the battens. The thick, asphalt-impregnated paper provides a secondary barrier against heavy, driving rain. Working meticulously across the steep pitch, the builder overlaps each row to shed water downward. The black surface absorbs the sun's heat, further baking the waterproofing oils into a solid shield. The roof is now entirely watertight, ready for its final armor. Peeling the protective film reveals the factory-coated finish of the steel guttering. Metal brackets are clamped and bent to the exact angle of the roof pitch. Chiseling shallow mortises into the wooden fascia allows the metal gutter brackets to sit flush. Dropping the long green channels into the brackets establishes the drainage system, capturing and redirecting rainwater away from the foundation is crucial. Pooling water would quickly rot the lower sill logs and undermine the concrete piers. The slight slope of the gutter ensures gravity pulls the runoff safely into the surrounding forest. Corrugated steel roofing is lightweight, heavily galvanized, and practically impervious to the elements. Sliding the massive favon green panels over the black underlayment locks the cabin away from the weather permanently. The deep ridges in the metal channel water downward and give the thin steel incredible structural rigidity. Walking the ridges of the newly laid steel requires caution to avoid denting the thin metal profiles. The final sheets overlap the previous courses, creating an unbroken steel watershed. Capping the peak with a custom folded ridge trim seals the most vulnerable seam of the entire structure. Screws with rubber washers pin the metal into the wooden battens beneath, compressing the rubber to create thousands of tiny, waterproof gaskets. The green finish visually anchors the cabin, blending the sharp angles of the roofline into the forest canopy. Inside, masking tape protects the glass as a clear, oil-based glaze is brushed onto the window sashes. The oil penetrates deep into the pine, repelling moisture while highlighting the natural grain. a sharp hand plane shears away the rough saw marks, truing the edge of the board. Preparing the timber for the window frames requires precise tolerances. Warping or uneven wood will let freezing drafts bleed into the heated interior. The heavy outer casings are drilled and screwed together directly on the floorboards, guaranteeing a flat assembly. Placing the frame into the log wall opening requires a level to ensure the window will operate smoothly. Heavy screws anchor the light-colored pine firmly in. A hand-cranked drill bores clean pilot holes for the corner joints, preventing the dry wood from splitting under the pressure of the heavy fasteners. Closing the door on the elements transforms the timber shell into a home. What was once a scattered pile of raw pine logs now functions as a unified, weather-tight system. The thick walls hold the heat, the metal roof deflects the storms, and the solid foundation grounds it all in the remote earth. It is a refuge built by hand, earned through persistence, and perfectly adapted to its landscape. Some things are worth the long road back.